Hello, everyone, and thanks for joining us today. I am interviewing Freddie from NewGen Audio. He's the product specialist there, and I'm really pleased to have you on the call today with us, Freddie. Thanks for your time.
It's a pleasure to be here. Thanks for having me.
Right on. So I had gotten in touch with NewGen several months ago, maybe more than several months ago, because I did a video on my YouTube channel about mono bass and how I felt like there was some value in leaving some stereo sides information in that. And they have an amazing set of plugins for that. They have Stereoizer, Stereo Placer, Mono Filter. And so I've been using that software. And so I've been in touch, and I got in touch with Freddie about that. And that kind of led us to this discussion, which is going to be about reverb. So NewGen has come out with a reverb plugin called Paragon, which I love covering audio software that pushes the edge of technology. And I usually don't bother to cover something unless I feel like it's doing something new, unique, innovative. And that's definitely the case with Paragon. NewGen has done some research that's been published in the AES journal about modal decomposition. We're going to get into what that is. We're going to go super nerd here with Freddie. And
Yes.
basically, they've come up with a new approach to convolution reverb, which is really promising, really interesting, has applications for video, post-production, music for picture stuff, sound design, and we're going to be talking about its applications in the field of music. So yeah, maybe Freddie, you could start off just by introducing us to the two general approaches to reverb, the algorithmic approach and then the convolution approach, and maybe just compare and contrast those a little bit for us, for those of us who aren't aware of how the technology actually works under the hood.
Sure. So, as you've pointed out, Drew, there, broadly speaking, are two approaches to reverb. So there's algorithmic reverb and there is convolution reverb. Algorithmic reverb is basically what it sounds like. It is artificial reverb which is created using essentially a mathematical algorithm. So what that means is you have an extremely flexible reverb because it's not based on any kind of real world thing. So you have a huge amount of flexibility, huge amount of tweakability within a lot of algorithmic reverb plugins. However, because it is essentially based on numbers rather than based on any kind of real world space, it does mean that it can be lacking in realism. And that doesn't always matter. Sometimes you don't want things to sound like a real space, but that is the main drawback. Convolution reverb is reverb which is based on the sound of a real space. So that can mean that you have less tweakability because you're relying on what did that space sound like when the what's called an impulse response was recorded. Whoever did that, whenever they did that, wherever they did that, you're kind of relying on a lot of different real world factors. It can be possible to tweak a convolution reverb, but often that ends up with kind of unwanted artifacts. So you might end up with time stretching, or you might end up with kind of repeated samples, or things that can, particularly in sort of a quite an exposed recording, can be really obvious and can end up being quite ugly sounding, and ultimately that kind of undermines the realism as well. So just to clarify as well, is it worth me explaining what I mean by an impulse response?
Sure, let's do that, because some people will have heard of that and some people won't, and I think it's useful territory, especially around convolution reverb. So yeah, let's do it.
Sure. So an impulse response, or you'll often hear these referred to just as an IR. An impulse response is a recording of how a space reacts to basically every frequency within the range of human hearing. So usually if someone is recording an impulse response, they will take either one microphone or more likely an array of microphones. They'll go into a space, say a church or a cave or whatever it is, set up their recording array, and they will either, the two most common methods of generating essentially every frequency in the range of human hearing is you either bring a loudspeaker and play what's called a sine sweep through that. So that is a sine wave sweeping from, usually from 20 hertz, which is around about the lowest frequency that the human ear can determine, and 20,000 or maybe 22,000 kilohertz. So no, not 22,000 kilohertz, 22 kilohertz. Yeah. So a sine sweep would be kind of a boop, kind of. This
is very similar to what we use in acoustic testing. So we would use sine sweeps to be able to test the frequency response and decay characteristics of studios, and we use sine sweeps extensively for building this control room.
The second method I was going to talk about was a gunshot. People will often record it. I assume probably firing blanks rather than an actual bullet. Depends how much you love to live life on the edge. But so I think that you would still use a delta function when you do what's called, so in like a standard convolution reverb, you would take that recording of the sine sweep or the gunshot, whatever it is, and you would do what's called, you would deconvolve that sine sweep.
But basically anything very short, very loud, and containing all frequencies will work. Basically, and gunshot's going to be a good way to do it. Hey,
exactly, and what you're doing is you're trying to have a recording which demonstrates how a space responds to every frequency. And then once you've kind of deconvolved that, the idea is that you can play dry audio through that impulse response and get something which sounds certainly as close as you possibly can to what that audio would have sounded like in that space at that time on that day with that array of microphones and
understood.
So
yeah, if you have the input dry and then you have the output, and then the deconvolve process is like an extrapolation, an algorithmic extrapolation of removing the input from the output, and then you can get what you would do in the convolution kernel to be able to create that. Okay, great. Yeah, that's pretty clear. Thanks for walking us through that. So coming back to the convolution reverbs, just to make sure I've got what you said correctly. So the algorithmic reverbs, they're great because they have parameterization. They're very customizable. You can have a lot of flexibility with them, but they can sound synthetic, which isn't necessarily a bad thing, but it might not be the approach you want. And then you have convolution-based reverbs, which are based on an audio recording of a real physical space. So you have kind of maximum realism, but you're confined by the original recording, things like length, for example, the decay length, and the acoustic characteristics of that physical space. And so if you want to customize it, if you want to parameterize it, change its decay length, for example, most significantly, or the balance of early to late reflections, or something that would change the sensation of the acoustic space, you're quite limited with convolution reverbs. And I certainly have observed this. I've used not a ton of convolution reverbs, but I've used a decent amount of them, and I've always found that anytime I try and stretch them or anything, you're noticing all kinds of grainy, time-stretchy artifacts, which can also actually be kind of neat for a sound design perspective if you want to create something really weird and unnatural. But usually the reason why we gravitate towards convolution in general is because we want realism.
Absolutely. And I think what's really cool about it is that it is about realism, but actually it does mean that you are able to situate a recording in a space that you wouldn't have necessarily been able to do the recording. I recorded several years ago now, probably 10 years ago, recorded some impulse responses of the inside of metal lockers at my old university. And I then ended up using that on loads of drum mixes. That for quite a long time was my favourite snare reverb, was the inside of a locker. Realistically, I would, you can't play certainly that locker was not big enough to play a snare drum inside of it. But that was an amazing sounding reverb. But I feel like that also brings us on to talking about me losing that file. I think it's on like an old machine of mine from years ago. That also brings us on to the other issue, or the other drawback with convolution reverbs, which is that you effectively have to have an impulse response saved on your hard drive for every type of reverb that you want. So if you want to have a small church, a medium church, a large church, a small hall, medium hall, large hall, and etc., you have to have an impulse response saved on your machine for every type of reverb that you might ever possibly want to use. And I'm sure you can imagine very quickly that starts to take up a lot of space.
Yeah, it's a big library for sure. Yeah, I can imagine. Well, that's neat. I also really like that idea of the recording of an inside of a locker. Just knowing, a bit about acoustics, you would get a crazy amount of flutter echo from the parallel, highly reflective surfaces. You might get some overlapping modes. It would be very resonant, and that's neat. Actually, a reverb trick that I used to use on snares as well was in Native Instruments Guitar Rig had a reverb in it. It was a tractor reverb, and it was basically like a very short delay. It didn't have modulated delays really. It was very much like a slapback, kind of like a flutter echo kind of delay, and it gave it a very metallic sound to it, which I really liked on kind of synthetic-y snares. So I can see why you may have opted for that on your drums. Yeah, that's neat. Well, thanks for that introduction. That really kind of gets us there. So let's get into what Paragon does differently from other convolution reverbs. Why don't we talk about the research? Because we can just touch on it, because I think it's really neat, because there was some research that was done by Jeremy Wells.
Yes.
About modal composition. So maybe we can just talk about that without getting super deep into it. We can talk about the initial research of the concept of how you can use modal decomposition and recomposition in reverbs, and then talk about the research that NewGen did building on top of that in terms of early late reflections. Let's just go into that for a few minutes.
Sure. It always throws me off when I hear someone refer to him as Jeremy Wells, because I know him as Jez. But so I'm always like, who's that? And then yes, Dr. Jez Wells, or Dr. Jeremy Wells, who was at the time at the University of York here in England. He, I guess, kind of recognised some of those drawbacks of convolution reverbs that I've just spoken about, and did this research into modal decomposition, which essentially, and I don't want to speak on Jez's behalf. It's his research, not mine. But my understanding of that is essentially he developed this way to deconstruct an impulse response into its kind of component parts, and then put that back together in a way that allows you to, as you said, parameterize, I can't remember what word you used, but allows you to affect change within that impulse response without using time stretching or the other kind of those kind of limited processes that we talked about. Essentially what ends up happening is, when you change any kind of parameter, whether that is the room size or the decay time or whatever it is, it deconstructs the impulse response and effectively creates a whole new impulse response. It creates like an imaginary version of the space. So that means that, say you have, I keep using a church as the example. I'm not sure why. I guess I'm feeling religious today. I don't know. But say you have one impulse response of a church, you can essentially make unlimited different versions of that church. So a darker sounding one, a larger one, a smaller one with a longer decay, one. You can even go as far as to be like, I want this particular church to be especially resonant around 700 hertz. Or like, I'm just kind of, completely random example there. So that was Jez's initial research, and he made a plugin basically for his own personal use, and I think some of his like PhD students' use as well. But it very much wasn't a marketable plugin. It wasn't something that would be user-friendly or kind of easy to understand for someone who hadn't been involved in that research. But that was the starting point, was basically this plugin that he made for his own personal use.
Okay. If I could hop in just for a sec there, I'll try and summarize that. So the example of a church is a good one, long decay times. And you said, ways of making it darker or more resonant. Now, you can do that in a regular convolution reverb, but the approach to doing that is usually using EQ, which is kind of unconvincing and cheap sounding to me.
Yes.
And I've never really liked just using broad spectral shelving EQ on the impulse response of a convolution reverb to try and tailor it. It's never to me sounded very realistic or very high quality to do that. It's just basically like EQing an audio sample at that point. But what Jez or Jeremy came up with was this neat concept of modal decomposition, and I just want to make sure I've captured this correctly. So it kind of uses a Fourier transform process, right, where it will take the impulse response and it will express that impulse response by breaking it up into a series of sine wave partials, each with its own decay rate characteristics. And this is really different from, if we use the term modal, because I'm an acoustician and I talk a lot about acoustics on the channel, I want to differentiate that. This has nothing to do with room modes, right? This is a very different piece of terminology. So he's breaking up the impulse response into a series of sine waves, just like with the Fourier transform process. And the sine waves are represented in each one has its own decay rate characteristics. And that's how the deconstruction process works. And then once you have all those partials, you can change them, modulate them, adjust their amplitude, adjust their decay rate characteristics digitally, algorithmically, and then they're resynthesized into another audio-based recording at that point by Paragon. Is that kind of how it works?
That's certainly my understanding. I think you've read Jez's research more recently than I have. So a lot of the technical terminology there, you're probably a little bit more switched onto than me even. I think that's how it works.
That was my take on it anyways. And it makes sense to me.
That lines up with my understanding of it as well. Yeah. So cool. I'm glad that we're on the same page there. I think it's important actually that you mentioned that term resynthesis. I don't think I mentioned that at all in my explanation, but that is kind of, that is what this entire process has ended up being called, is IR resynthesis. So that's kind of, I think it's good that you mentioned that, and we probably will keep coming back to that term.
It's kind of like Star Trek with the transporter, right? Where you deconstruct someone, they go into the pattern buffer, they beam them somewhere else, and then they resynthesize as themselves. Well, hopefully, but in this case, you're resynthesizing as something a little different.
Yeah, like maybe cool. if I did that, I'd resynthesize myself as being slightly taller or slightly less of a beer gut or whatever.
Wouldn't we all?
Yeah. I think as well, you kind of touched upon something. You were talking about this idea of like EQing a convolution reverb, and I think you're right that you can achieve all these things in Paragon without EQing. But I think it's important to maybe flag up what you are actually doing instead. So a big part of what you're able to do in Paragon is changing the frequency-specific decay time. And this would be actually a really good moment for me to just briefly,
please do,
I think, show the plugin UI. This is Paragon. This is the stereo version of Paragon. I'll make it a little bit bigger if it wants to play ball. So this is the IR panel within the plugin, and if I go to the IR panel and then to the what's called the modifier, this is where I am able to adjust the frequency specific decay time. It looks a lot like an EQ, which is nice because it means that it's easy to understand.
Yeah.
Basically, anyone who's worked within a DAW probably understands how EQ works. So I'm able to add however many kind of nodes that I want. I'm able to adjust the Q of each of those. I'm able to adjust the frequency. I'm actually able to adjust which channels this affects as well. I'm using the stereo version here, so that might be less of a factor. But for example, Paragon does go up to 714 surround, so that's 10 channels of, no, not 10 channels, 12 channels of surround, my apologies. So I might decide I want to adjust the frequency specific decay time, but I only want to adjust that for the LCR, the front 3 channels.
Wow.
Or maybe I only want to adjust it for the back channels, or just the sides. Or maybe, I mean, it's unlikely you would do this, but it might even be that you decide I only want to affect just the right side rear channel, and everything else is as it was. You know, you have that level of flexibility. But the point is that you are able to adjust every frequency band independently, and rather than just turning up that frequency band like you would with an EQ, you're actually changing the impulse response itself. So a really useful way of taking advantage of this is, say for example, if you have a vocal with a really long lush reverb on it, like maybe you're going for like a Cocteau Twins type thing, but perhaps you want there to be a little bit more transient detail in the vocal. Maybe you want to be able to understand what the person's saying, but you don't want to reduce the overall decay time. You want this really long, really lush reverb.
Right.
What you could do is zone in on specifically the fundamental frequencies of that person's voice, wherever that would be, probably, I don't know, maybe around 500 hertz or so, depending on their voice, and reduce the decay time just for that frequency band.
Yeah.
Without
so you reduce the
the rest of
masking
it.
effect of the next word syllable transient of the vocal. Love
exactly.
that.
So then you still have this long, lush reverb on all the overtones. I'm getting tongue-tied. On all the overtones, harmonics, and so on. But the actual fundamental frequencies of the voice have a shorter reverb. And yeah, you don't end up with that kind of, as you say, the masking. So you're able to capture more transient detail without kind of losing out on the artistic intent, which in this case would be having a super long, super kind of washy reverb.
I love it, because the approach that I've used in the past when I've wanted a reverb that is both long but doesn't mask the vocal is I've used sidechain compression after the reverb and sidechained to the dry vocal. But that being single band, typically it just pushes down the entire reverb. So this would be a really neat approach, because as well, the other really big thing I want everyone listening to get with this is that although this looks like an EQ that Freddie's been using, this is affecting decay rate characteristics. And so this makes the ability to model a physical space just next level, because again, coming back to the field of acoustics, any physical room that you're in, your perception of the sound in that room and the frequency balance is highly dependent on the rate of decay of all the frequencies. And in any physical space, doesn't matter if it's the top studio in the world or if it's a cave, has different decay rates for each frequencies. The best studios in the world have very even decay rates, and that's usually what you want as an audio engineer. This room that I'm in has a sub 200 millisecond decay rate down to 30 hertz. And then it lifts and extends a little bit. It's very hard to control low frequency decay rates. It needs a lot of acoustic treatment. But in most rooms that you're in, the low frequencies are going to ring. They're going to have decay rates 1,000 milliseconds, 1,500 milliseconds, or sometimes more. And especially in churches and halls of worship and things like that, you get huge long decay rates. And it's different for every frequency. What Paragon's able to do is very realistically model that. And it's doing that by playing with the sine wave partials. It's not doing it by processing the audio directly, which can create artifacts. So yeah, this is fascinating, and this is one of the many reasons why I wanted to have this conversation with you. So thanks for showing that to us, Freddie.
No problem. It's maybe worth mentioning actually as well. I was only using bell curves on the frequency interactor there, but you can also do a high shelf, a low shelf, and so on. So it can, visually at least, do everything an EQ can do, but as you say, it isn't interacting directly with the audio. It's interacting with those sine wave partials.
Yeah, love it. Yeah, Fourier synthesis and is just a fascinating topic. At some point, I'm going to have to find somebody who specializes in that and do a deep dive video, because I still only partially understand everything you can do with it. But the more things I encounter with audio, especially as I talk to plugin developers and learn more about, anti-aliasing, low-pass filters, and things like that, the more I understand how Fourier synthesis is and the Fourier transform is involved in everything and how significantly it impacts everything. So, great. Well, then to wrap up our conversation on the research, so you had some folks internally at NewGen build on the research that Jeremy Wells did and published a paper in the Journal of the Audio Engineering Society. And that was, maybe you can go into a bit about what that was and then how that led into development of Paragon.
Sure. So, there was some research done internally by two of the guys at NewGen. That was Patchy Monadero and Mike Howard. You mentioned earlier this idea of balancing the early and late reflections within a reverb, and that was fundamentally what their research was to do with. They were trying to use that kind of balance of the early and late reflections in order to give the impression of depth without actually adjusting the sound of the reverb. So it's really easy with any reverb, really, to make something sound further away by either increasing the decay time or maybe adding more of the wet signal and less of the dry signal, or whatever it is. However, we've talked already about realism. That isn't a very realistic way of doing it. But what Patchy and Mike found was that a really realistic way of doing that is to adjust the balance of the early and late reflections in order to give the impression of depth. I'll share my screen again. I've probably closed that slightly preemptively.
Sure. Yeah, it would be great. We're talking about it. Let's hear it. Hear what you mean. And sure. As you're getting that set up, I can speak to that a little bit, which is, anytime you're in a room and you have reflective boundaries, any physical space that you're in, human beings are extremely sensitive to acoustic cueing. And in fact, if we're in an anechoic chamber ever that is completely devoid of any reflected sound, it's quite easy to become unnerved, and some people actually freak out within a matter of 30 or 40 seconds and need to leave because they have so much anxiety about the lack of acoustic cueing. We're so accustomed to it. But when you're in a physical space and you have reflective boundaries, you have a combination of these reflections, early and late or diffuse reflections. And the early reflections are usually hard specular reflections. They're direct reflections off of the hard surfaces around you. So those would be your ceiling, floor, sidewalls, maybe a desk in front of you. Those are very fast. They're within a few milliseconds to maybe 10 milliseconds. Sound travels about 1 foot per millisecond. So if you have a wall 5 feet to your right, you're going to get a reflection within 10 milliseconds of travel, right? So, and then you have the diffuse reflections, or the late reflections, late energy, and that's as a result of when sound strikes a whole bunch of different surfaces through a more tangential or oblique path, and then reaches back to you kind of as more of a cloud. It's more spread out. It's you're not hearing these individual, discrete early reflections, and the combination of those two types of energetic reflections comprise our perception of the acoustic characteristics of whatever space we're in. So we're going to get a demonstration of this now. So that's great. Thanks, Freddie.
Sure, no problem at all. Yes, so the control that we're looking at here, we've labeled in Paragon as mic distance, but what this is actually doing, you may have already guessed this, but what this is doing is adjusting the balance between the early reflections and the late reflections. So if you have the mic distance at 0%, then that is the loudest possible early reflections and the quietest possible late reflections. That 100% is kind of the unaffected version, or at least for that particular parameter. Clearly, you might still have changed other parameters within Paragon, but the 100% is kind of default mic distance. And then if you go all the way to 200%, that is the furthest away something is going to sound. So that's the loudest late reflections and the quietest early reflections. Because we've kept talking about churches, I've picked the large church preset within Paragon. I think it's this is a slight side note, but I think it's worth mentioning that the presets within Paragon are not the same as impulse responses. So we've made a bunch of presets and you can save your own presets. However, because we were talking earlier about how having a lot of impulse responses takes up a lot of space on your machine and isn't necessarily the best use of that space. If you go onto the IR panel, you've got the list of the actual impulse responses themselves.
There's the recorded impulse responses. Yeah, gotcha.
Exactly. And then all of our presets are based on those impulse responses. But so, for example, we have the church impulse response. There's, I think, about 4 different presets based on that. So yeah, that's just a clarification I thought was worth noting. I'm gonna try. I've got the stems from Radiohead Reckoner on here.
Sure.
Which are freely available for anyone who wants to try them out. They're very easy to find and not via illegal means either. Radiohead did make these.
They released these. Yeah, gotcha.
They did.
Okay.
Cool. So I'm gonna put some reverb, the large church, on Tom York's voice. I probably should have checked this beforehand. It may sound mad to start with, so my apologies. But what I'll do is I'm going to start at the kind of neutral point. Well, once I get it sounding decent, I'll start at the neutral point of the mic distance, and then we'll go closer and we'll go further away. I'm not going to drag that in a smooth motion, and the reason for that is because you might notice a lot, not every parameter, but a lot of the parameters in Paragon, when you change them, you have a little spinning wheel that appears in the top right. And what that means is that the resynthesis process is happening now.
Right.
That's and so if you are continually changing parameters, then that's potentially going to be something that might slow you down. That's when you might get artifacts, not because of the plugin itself, but because it's just trying to do too much. And if your machine isn't the most powerful, which unfortunately mine isn't, that might cause problems. So what I'll do is I'll probably kind of do it in intervals. But here we go. Let's hear Tom York. Tiny bit. That's, considering I hadn't checked that beforehand, that actually sounds surprisingly all right. Not exactly how I would do it in a mix, but there's Tom York in the church. I'm going to bring him as close as he can be, and then we'll gradually move him further away. Here we go.
Right on.
Here's me thinking there was another line there. I'm just gonna keep going. Hang on. So I'm sure you get the idea. Yeah, there was one less line of lyrics than I expected there, but basically, yeah, the idea is that you should hear the sound of the audio source, whatever it is, whether it's a vocal or a guitar or even Foley if you're using this for audio post or whatever. It should sound like it's getting further away, but the actual character of the space should sound consistent, should sound the same. And I would encourage people to try that out on their own mixes. You know, it's great being able to do these kind of audio demos here, but I always feel like it's much better having that kind of tactile that kind of tactile interaction with it. All of our stuff has a free 15-day trial as well if anyone wants to give that a go. But a really cool way of using this, in my experience, is if you have two instances of Paragon where the settings are exactly the same, apart from the mic distance control, you can send different elements of a mix to those two different instances of Paragon in order to situate them in the same space but different places in that room. So that's another way, almost similar to panning. You've got your left and right, but this is actually front or back of the room. So it might be this isn't the only right way of doing things, but if you're the type of person who mixes by trying to situate your musicians on a kind of virtual stage, then you might have the vocals sent to your closer mic distance Paragon instance. You might have your drums sent to the further away one. You might, you can experiment with that as much as you need to. You could even have some elements sent to both, and then adjust the level of those aux sends in order to kind of blend. So that's I think a really cool way of using the mic distance control to actually situate everything in the same space without having it interacting with the reverb in the exact same way.
Love that. And that's a great way. Like I am one of those engineers in that camp of, I always think about my sound space and where I'm placing elements in the mix. I think of it in terms of a 3D box, 3 dimensions. And the front back dimension is what you might call depth staging. And I definitely think about, in a mix, if you want your mix to sound deep, if you want your mix to sound 3D, which I generally do, you want that separation, that other dimension of separation, having the ability to control things that sound really dry and in your face, and then things that sound really kind of wet and affected and further away from you, is a really important trick to have in your bag as a mix engineer. And this is a different approach. I hadn't thought about doing that. So again, this is great. I get to learn something new. I wouldn't have thought to use multiple instances of Paragon with the same algorithm, the same preset maybe, but different mic distances to be able to use in-depth staging. So that is something I am most certainly going to try out, Freddie. So thank you so much for that.
No problem at all. I think this is slightly related, but it's just reminding me as well of my other kind of, this is my top tip for kind of more subtle or more unusual ways to use Paragon. We've talked a little bit earlier about mid-side processing. I really like to... So although Paragon itself doesn't have a mid-side mode, we have another plugin called Sigmod, which is a modular utility plugin. But one of the modules that it has is a mid-side encoder and decoder. And what I will sometimes do is place 2 instances of Sigmod either side of Paragon or another reverb, whatever it is. And in this case, I would have Paragon as a multi-mono instance rather than a stereo instance. And I would bypass the left, which in this case would actually, because of Sigmod, would actually be affecting the mids. And I would then have my reverb just on the right, which is then only affecting the sides. So that's a way to kind of use reverb in a more subtle way. For me, that sorry, I thought I'd turned off notifications. I've just got a Mattermost notification, which is throwing me off slightly. For me, that's a really good way of creating a kind of subtle room sound. If you don't want it to be obvious that you've used a reverb, but you want kind of a subtle ambience to actually kind of maybe even to make something sound a little bit more lo-fi or just a little bit more kind of homely, having reverb just on the sides and not on the mid channel is a really cool way of doing that.
Yeah, that's really neat. I like that approach to being able to mid-side encode something without having a mid-side encoding it directly in the plugin. So that's great. I haven't checked out Sigmod before, but I'll have to. And yeah, I like that that level of control in being able to put reverb and focus it just on the side channel or just on the mid channel. It gives you a lot of flexibility, and mid-side processing in general in mixing is a next level. It's an advanced technique to use, or maybe not so advanced. I know there's engineers that kind of grew up in the day and age where you were doing a lot of mid-side recording with mics. I was not one of those people. I kind of had to learn about mid-side processing in the digital realm. But that's really smart. And as we go through any other kind of little tips and tricks you have that you do with Paragon, I invite those, please. That's great. I like to know those little, this is how I use it. It's one thing to know the manual and to know what all the parameters do. It's another thing to be, you're obviously an adept engineer. It's nice to know how you're using it.
Thank you.
Great. Well, maybe why don't we take a look now, and you can give us a tour through the interface, because it is. You've got a couple of panels there. You've got the IR panel, you've got the main panel, and maybe we can just start off with a tour, starting with the main panel that you've got up there of some of the significant things to call attention to.
Absolutely. So, yes, if it isn't already apparent, this is Paragon. So when you first open the plugin, you will be greeted by this page. This is the main panel. This has a lot of the controls that you would find in a typical reverb. So you have your pre-delay, you have your decay time, you have your room size, and you have your brightness. Some of the other controls on the main panel are, first of all, you have in the top left here a high pass filter and a low pass filter. Pretty much all the controls within Paragon only affect the wet signal. So this will be a high pass and a low pass, just affecting your wet signal. That might be useful just as a quick way of maybe removing some muddiness from the reverb if you don't want to kind of go into like the frequency interactor that we looked at before. We also have at the bottom the mix, so that's a wet dry mix, and the trim, that is boosting or cutting the wet signal again. Ideally, so we have attempted to make it so that all the impulse responses and presets are roughly matched in level, but because they all respond to different frequencies in different ways, depending on what audio you're actually putting through Paragon, sometimes you might switch to another preset or another IR or whatever it is and find that there's a big boost or a big cut in volume. So you can use that trim control to make sure that doesn't happen. And then in the top right here, we have the crosstalk. So the crosstalk is, I don't think it's completely unique, but it's one of the more unique features in Paragon.
Yeah, I hadn't seen that before, and I was actually, after reading the manual, I was wanting to ask you about this so you could kind of explain it to me, because I wasn't super clear on what it does, or maybe in particular how you might use it, some use cases.
So the crosstalk essentially determines how much of the dry signal from one channel is sent to the reverb in other channels, and also vice versa. So it's basically a little bit like if you're using analog gear, like an analog tape machine or something like that, you might find that you actually get surprising bleed between channels. This effectively does the same thing. So like I say, if you have two channels, as I do here because I'm working in stereo, the higher the crosstalk, the more bleed there is from each of the dry signals into the wet signal in each channel.
So if you say, for example, we're putting this on like a drum recording and there was a hand drum or something that was panned hard left, normally that would not affect the right channel in the reverb at all, but with crosstalk increased, then it would, and then that would have the impact of kind of making the reverb sound a little bit less stereo, maybe a little bit more mono, kind of like stereo linking.
So the idea is that in a space, sound doesn't reverberate just in one direction. So if you have a sound, even if it's panned all the way left, it isn't only going to reverberate to the left. So it's another way of increasing that kind of realism and situating everything in the same space. if you're working in surround, this gets really interesting because there are controls over, for example, whether there is crosstalk in the LFE or in the center channel, things like that. I think by default, the LFE is kept out of the crosstalk completely, although you can enable that if you want. The center channel has crosstalk coming out but not in, and the reason for that is to keep the clarity of dialogue. If you're working in audio post,
right,
usually your dialogue is going to be in the center channel, and you want that to be as clear as you can, so you probably don't want reverb crosstalk coming into the center channel. So yeah, I'm pretty sure by default in surround, most of the channels have it coming in and out. The LFE has no crosstalk, and the center has crosstalk out but not in. But those are all tweakable, and even if you actually, well, I'll get onto this in a minute, but there's even more control over that in the I/O panel. Cool. Next is the IR panel, which, oh, sorry, I'll
just stop you for a sec there, and that makes complete sense because one of the things I've done recently is I've worked with SonarWorks, and I've done a official video series for them on mixing it on speakers, mixing in headphones, using monitor calibration technology that they produce, and using Room EQ technology that they produce. And so I've gone really deep into the field of, what's it like mixing and listening, experiencing music on headphones, which are not stereo. They're binaural, right? So you have discrete coming in at right angles, sound presentation, super wide soundstage. And then the differences between listening on monitors is that you don't have these discrete channels. Sound from my left monitor is going to be striking my right ear at a very slight delay, and it'll experience a bit of anatomical head shadowing. So it'll be slightly spectrally different, and it'll be a bit lower in level. And same thing, the sound from my right monitor will be striking my left ear. And that's what you would generally refer to as crosstalk, is, if something's hard panned left on a set of stereo speakers, you're going to hear it in the right ear. And it's the same thing with echoing or reverberation in a reflective sound space as well.
Exactly. I guess what you're talking about there with SonarWorks, I imagine, is probably using slightly different techniques to achieve a similar end result, I would assume.
Yeah, you're feeding a delay network in this case that creates or maybe it's not a delay network, it's the modal decomposition process and the recomposition resynthesis process. But basically it's ensuring that the sound that would occur on one side of the stereo field or in immersive, one channel in the immersive, is being fed and feeding the reflected ambience in the other channels, such that it, like you said, that happens in a real room for sure. You can't stop that.
Exactly. So the next panel is the IR panel, which we've already looked at a little bit. So we've looked at the frequency modifier, but this is where you, first of all, are actually able to choose which impulse response you're using. So if, rather than using one of our presets, you wanted to build a convolution reverb from scratch, you would probably start here and choose one of these impulse responses. You then have a spectrogram view of that impulse response, and if I go to the modifier, I'm able to amend frequency-specific decay. And if I go back to the spectrogram, I should be able to see that. I mean, I'm doing something quite extreme here, but it should. Do you know, it's not actually had as much of an impact as I would have anticipated. But point being, that'll be why I'm on the amplitude rather than the decay. That's my bad. Apologies. So if I go onto the decay, then it should.
There we go.
Or of a noticeable effect. There we go.
We're seeing it. Yeah.
I was thinking, like, why is this not doing what I expect? And that's my own silly fault, because I was on the amplitude rather than the decay. The amplitude,
so does the amplitude area function like a standard EQ then?
Basically, yes.
Yes. Okay. So you do have both worlds that you can play in, the decay or the
decay.
Straight up amplitude. Okay. Yeah, I like that.
So my apologies if I was on the amplitude when we spoke about that earlier, but hopefully it's still
it'll translate.
Got the information across.
Yeah, totally.
You also have test sounds that you can play. That's if you don't have any audio in the project yet. These are just some simple bits of audio.
Yeah, could we hear some of those?
We have, by all means, there's some guitar here. should be. Hang on. I don't know why that's not working, but it's not right now. So
yeah, no worries.
Yeah, I'm not sure. There is audio coming through because I just checked the.
Yeah, we can just use the stems that you have in the project. That's no problem.
Yeah, sorry about that. But so it should play some sample audio. There's probably something strange I've got going on in my room
with our routings in Pro Tools to get them into the stream. Yeah, no problem at all.
Exactly.
I did want to ask you actually in the reverb model. So it's for the impulse responses. One interesting thing to talk about there is that what you guys have recorded. So when you click in there and you can take a look at the different spaces that you guys have for the impulse responses. The initial reaction I had when I looked in there was like, oh wow, there's actually not as many as I thought, and they're kind of, like some of them are kind of weird spaces. I was kind of looking for some things that I would normally see, like maybe a plate or a room or something. But it would be interesting if you could touch on kind of why you don't need that many impulse responses in Paragon because of the way it works.
Sure. So, yeah, this is a bespoke library of impulse responses, which was recorded by a guy called Rince Velkman, I believe is his name. He did that on NewGen Audio's behalf. They were all recorded in B format, ambisonic, 96K recordings, if I remember rightly. So it's a really high quality bespoke library. These, to my knowledge, are not all the impulse responses that he recorded. This was actually kind of during peak COVID lockdown, kind of lockdown number 1, he recorded this library of IRs. And that, although obviously it was horrible in a lot of ways for the world, I think it was quite helpful for Rince because he was going to all these deserted places and recording these impulse responses. He sent us this library of impulse responses that we commissioned, and then our dev guys kind of worked out which of those were the most useful within the technology that Jez had developed. And then there's an additional process which needs to happen to that impulse response before it can be imported into Paragon. So there's a whole extra bit of code which I don't necessarily pretend to understand, but I'm led to believe to do the processing for one impulse response takes one of our programmers a whole day. So it's kind of quite a time-consuming process.
Quite an ingest process.
Yeah,
that's neat that you recorded those in 96K and in ambisonic. So that again increases the amount of realism. Neat.
So that means that means that we can essentially represent those impulse responses in any channel count. So right now it goes up to 714, but I believe we're looking at introducing 916 as well. So that, again, less useful perhaps for music guys, although Atmos for music is obviously becoming more popular, but definitely for audio post guys that's really useful. So we have this list of impulse responses, and as you've said, Drew, it's not a huge library, but because of the level of flexibility, again, without the kind of artifacts that we've talked about, you find, certainly in my experience, you find that this library of IRs is enough to create practically any reverb that you might need. And if you go on the presets here, this is just the stock presets, but you can see there are a lot more reverb presets made from those impulse responses. And it does just mean that
sense. Yeah, and there's a lot of the ones that I'd be looking for. Oh, small room, small club, small chamber. That's the stuff that I look for as an engineer because I know what those are kind of I know more or less what I'm gonna get. So that's
exactly.
Really neat, and it's through the modal decomposition process, breaking it up into the sine wave partials and the resynthesis process that you're able to do that in a way that's basically lossless. You maintain all of the realism, so you don't need all these impulse responses because you have the parameterization available through the decomposition and resynthesis process from the original IR.
Exactly, and so the names of the reverb models are quite literal and aren't necessarily the most helpful for audio engineers, and that's why we've got this kind of preset library as well.
Right.
The final
Yeah,
thing
that
on
was
this
my
panel.
misinterpretation when I opened this up. Is I went straight to look through the library of IRs, and I was like, "Wait a second! I'm trying to process a drum kit. How do I? What do I? Where's my drum room impulse
Yeah.
response?" And then, yeah, then I realized, right? No, it's in the presets that you go to. You know, unless you're wanting to really go under the hood, you don't necessarily need to play with the IRs. Although I'm sure that'd be fun for a Sunday morning over a cup of coffee sometime.
Oh, absolutely. That's a lot of fun too. So Ben Jones, who designed all the presets for Paragon, he is actually a really great mix engineer and mastering engineer himself. He works on a lot of like metal and hardcore kind of stuff. So he has made a lot of these presets with music mixing in mind, as well as audio post mixing. So yeah, the final thing that I want to talk about on the IR panel is this complexity control. This essentially controls how much of the information from the impulse response is included. So if you have complexity full, you'll notice that as I'm turning this up and down, the amount of information that's actually showing on the spectrogram here is changing, and that's because we find that in a lot of situations you don't necessarily need all the reverb information. In fact, if anything, that adds clutter to your mix. So there's a difference between if you have a really dense piece of music that's like a 6-piece band and 10 different vocalists and whatever it is, you probably can have the complexity on the reverb quite low, so you're just getting kind of a flavour of the space without all the detail. Whereas if you've got a really sparse recording of one acoustic guitar and a vocalist, you might want to have a very complex and lush sounding reverb, so you want all that additional information, even the info that perhaps isn't the info that perhaps isn't integral to the sound, but you maybe just want to fill out your mix a little bit more.
Yeah, totally. So you could use that almost like a density, almost like a density control. Like it's, yeah, I
Exactly.
get it. Yeah, something that can make the reverb a little bit thinner, a little bit more transparent to tuck it into a dense mix, or yeah, like you said, if you have something a bit more exposed, you can make it more full. I like that. That's great. I would say my comment on what I've seen so far is the parameters are mostly very intuitive, and that's really important to me to open up a plugin. I like to be able to open up a plugin and use it without reading the manual, although I always do read the manual eventually. But it's also, I think the parameters that you have provided are really useful parameters. You know, like the tweakability factor is you've given people the controls they need, and haven't cluttered up the UI with things that maybe are inconsequential.
Thank you. Well, yeah, I would say the really great thing about our dev team, particularly on the Paragon project, is their ability to take this technology that Jez Wells had basically made for his own personal use. Our dev guys were able to take that technology and work out, okay, which of these features and which of these controls is actually going to be useful to not necessarily the average audio engineer, but like an audio engineer who isn't specifically Jez Wells. You're kind of trying to broaden it beyond it being useful for this one guy is kind of the thing. And I think, you know, what you're saying there speaks to the fact that our dev team did an amazing job on that, of actually getting to the core of it and thinking, okay, which of these controls are kind of extraneous and are just going to be a distraction, and which of these controls are something that we should implement and have front and center on the plugin, and so on. The final screen that I'll show you on this is the I/O panel, which is where you do have individual control over each channel. So you're able to solo each channel. You have an input and an output trim, again for each channel. You have individual high pass and low pass for each channel. Again, these are maybe a little bit more useful in a surround context, although there's no reason you shouldn't use them in a stereo context. You have individual pre-delay for each channel, which I think there's scope for some really interesting effects there.
I've never seen that on a stereo reverb before, actually.
and then you also have control over the decay time. So this is, you'll see this is a multiplier, which the main panel is also a multiplier. So this is, on the main panel, it's multiplying the original decay time. And then on the I/O panel, it's multiplying the decay time that you've set on the main panel.
Yeah, so, I was going to ask how those interact with each other. I was like, do they override each other, or so they scale based on what's set on the main panel? That makes a lot more sense and is much more usable for sure.
It's kind of probably best not to think about it too much because your head might explode, but it's kind of it's a multiplier of a multiplier. And then the final thing is you have individual controls over the crosstalk. So what percentage is coming in, what percentage is coming out, and so on. And that's just about everything within Paragon.
This kind of reminds me of an airplane, because if you're in a little Cessna or anything, you've the pilot, co-pilot, you have two sets of controls. In that case, you don't want scaling. You want complete override.
Yes.
One person's pushing down, one person's pulling up. The plane just stays dead center. But no, this makes a lot more sense where the controls don't override. It's just adjusting or scaling based on what's set on the main panel. So I dig that. Well,
it's a good job that NewGen turned down that contract from American Airlines.
Yeah, exactly.
Otherwise, we might have all been.
You don't want to be building planes with that mindset. So maybe you guys could help Boeing out with their doors. They need some help with that. Maybe they need some common sense.
Yeah, I'm easy to find.
Do those bolts up, guys. So maybe now we can go into some more extensive audio demos. I'd love to, now that you've given us a really wonderful overview of it, I'd love to hear a bit more about how you use it in action, maybe in a few different use cases. Feel free to do music, the stems that you have up. Feel free to dig into anything else, sound design, Foley sounds, anything that you might find for music, for picture, things like that. I'd just love to hear a bit about how you're using it on different things.
So the first thing is, and this is quite a subtle thing, but again, it's a really nice way of using it, I think. The first instance of Paragon I've got in this session is actually on the bass guitar. So again, these are stems taken from Radiohead, Reckoner. They're very well recorded. Nigel Godrich has done a great job on the production here. I'm not for one moment trying to suggest that I could have done a better job. However, in the interest of trying to demonstrate a few things, one of the things I ended up doing was putting an amp sim on the bass just to give it a little bit more kind of grind. This isn't a NewGen one, I'm sure you can see that. It's the SansAmp amp sim. I'm pretty sure this comes for free with Pro Tools, but I really like the sound of it. So I've added an amp sim, but then found, in fact what I'll do is we'll hear the bass on its own, and I'll bypass Paragon to start with. We can hear just with the amp sim. I think it sounds cool, but what I found was that adding that amp sim on there really got rid of any sense of space. So I'm going to bypass Paragon. We'll go to this amp sim, hear a bit of the bass. I'll maybe just turn it up a little bit as well, just so that people aren't struggling to hear. So it's, it sounds pretty good. It's got a little bit of grit to it, but I wanted to kind of situate that in a room. And we talked about like these mic distance controls as well. So it's kind of a subtle difference, but especially bring this closer and maybe add a bit more wet signal in here.
Oh yeah.
While the bass is still kind of central, there's something just a little bit more spacious going on there. And I think these are for me at least, my favourite ways of using Paragon aren't for really big dramatic reverbs. For me personally at least, if I'm doing something dramatic, I probably actually want something quite synthetic sounding. When I'm using like a realistic sounding reverb like Paragon, I'm going for subtlety like this. The other instance of Paragon in this session, I think, is on the backing vocals. Let me just have
Well, I
a
love
look.
that. Thanks for showing me that on the bass. And I think that's, I think sometimes people can be trained away from um, and scared of putting effects that involve any stereo width on bass elements. You know, a lot of people have been really indoctrinated to think that the entire, especially in the electronic community, which I'm in, uh,
Mm,
people have been really indoctrinated against basically to force your low end to mono. And it's totally not necessary as long as the information correlates really well. And in fact, I really like the dimension that that adds. Like you said, it's very subtle. You're just using it as a gentle touch. You're way down there, 15% in the mix, and it's a very short decay time. But I loved what that added to the bass. That it took it from sounding really dry and too dry and one
yeah.
dimensional, and just gave it some very subtle but stereo ambience, and added realism and a three-dimensional aspect to it, which really is one of the big differences between a amateur sounding mix and a really professional sounding mix.
Absolutely. And I mean, for example, I wouldn't necessarily go as extreme as this, but like one of my all-time favorite albums is Paranoid by Black Sabbath. And all over that record, the bass guitar is basically panned. I can't remember which side, but it's mirroring the guitar. So the drums and the vocals are in the middle, and you've just got guitar to one side, bass to the other side, and that's for like 90% of the record. And it sounds
Not hard
amazing,
panned, though,
you know.
just panned a bit, or
Not hard pan, but like I would guess probably like 50%. Like
whoa,
it's far. Like it.
yeah. You don't normally
but it's
see that.
great.
That's a bold move as a
That's like
mixer. Yeah,
yeah, and that's obviously an extreme example. But for me, because I definitely at one point was really indoctrinated into that thing of like, oh, the bass has to go down the middle, the low frequencies have to go down the middle,
right.
and I think that's a useful thing to keep in mind, is that it's sensible to have the bass down the middle, but also it's not the be all and end all. You don't have to, and if you know, that's a huge record, massively influential record that sounds great. So many people love that record, and that's like a crazy production choice. So if they can do that, surely you can add a bit of width to the bass. Or like a guy called Rob Slater, a mix engineer I've worked with a lot. I can remember one of the first times we worked together, it was a track that had a bass guitar and a bass synth. And I think the bass guitar he panned down the middle, and the bass synth he had like slightly just off to one side. And I remember when I got the first mix back from him, I was like, hey man, did you mean to do this? Like, I assumed it was a mistake.
Yeah,
and he was
were
like,
you having a little whiskey in the studio last night?
Yeah. And he was just like, no, I did it on purpose. And I kind of was like, you what? You did it on purpose? But it's that. And then I was kind of like, yeah, like why? Who says you can't?
It works.
You know, it's sensible to have the low end, certainly the very, very bottom, kind of sum to mono, especially if you're like mixing or mastering for vinyl or like for the club, things like that. But actually, it's, you know, ultimately we're trying to do something creative here, you know?
Yeah. And I think the main
why
thing
not
is,
do something wild?
does it correlate? You know, it's, I think a couple things about that. One is I think a lot of people have monitoring systems where they have a single sub. And so if you're trying to engineer music and you're monitoring and you have a single sub that's already summing below the sub crossover point to mono, then you're not even hearing things that are in stereo, which is an incorrect monitoring setup. You know, I'm mixing and mastering on two Neumann KH420s, and my low end all the way down to 26 hertz is entirely in stereo. And I'll tell you, I hear errors in mixes that I would not have heard if the low end was forced to mono by monitoring with a sub. So that's one big point I want to make. And the other is that when you're producing and mixing in full stereo, full spectrum, all you have to do is, and if you're using techniques that involve a bit of stereo information on the bass, and I use techniques in my mixes where I have stereo information on the bass all the way down to 30 hertz. What I care about is that I'll force the low end to mono to check it, and I'm using low end correlation meters. and I'm taking a look. Does it correlate, or am I experiencing level loss when it's summed to mono, which oftentimes will happen if you're not doing things correctly, or I'm just hearing, am I missing something? Is there a really like phasey synthesized bass down there that is losing information? And that's where I get into using tools that you guys make, primarily Stereoizer, and using mono compatible techniques. Reverbs and things like that don't have to sacrifice mid information to have a little bit of low level information in the side channel.
Sure. Well, is that a good segue? Should we maybe talk about some of the Stereoizer and those focus tools? That's like the bundle that Stereoizer is part of.
I'd like to, but I'd like to maybe hear a little bit more just before we do of how you're using Paragon. I'd love to hear a couple of other use cases. You can use these stems or something else if you'd like to, and just hear a couple of other ones, because I've really gotten a lot of value so far out of what you've shown me.
Sure. I'll go for one more if that's okay, and we'll do.
Great.
Let's have a look. We have the backing vocals here, and then actually. That's a really useful jumping off point to the focus stuff as well. So I'll just kind of show you what I'm doing here. Again, it's just adding a bit of space. I'm, as I've said, quite into the subtlety. But here we are. So again, it's one of those things that it's like barely even noticeable, but we can do things like increasing the stereo width maybe to give that a bit more. Could move the mic distance back a bit just to. It's like so subtle, but just.
But it does add, I'm hearing that, though.
Like
it really does add something
to things.
Yeah, it takes them away from kind of very dry, very forward sounding, especially on backup vocals. It's nice. Yeah, I've kind of always taken the approach of kind of washing the backup vocals out a little bit more and more of a significant reverb. But this is a neat approach to try out. I think I'm probably gonna, like you, use the room ambience preset a lot and kind of modify from that.
Sure. Yeah, I think so I've been recording since I was like in my mid-teens, and I'm now in my early 30s. So it's been a long time. But for probably a decade of that, I just thought I didn't like using reverb in a mix. I just was convinced I don't like that. Not for me. And I think it was because for me at least, there was this expectation of using it as an effect and using a dramatic sounding reverb. Whereas actually what I've really found is that I love just using really subtle reverbs that give things just a little push, a little nudge. I guess it's similar to people using layers and layers of compressors on a mix, but each of those is only kind of tickling the mix just ever so slightly. Yeah. I guess it's a similar approach.
Yeah, right on. And the Paragon stuff is amazing. I really, that's one of the things that I enjoy the most about what I get to do, is coming into contact with people that are doing the research, the people that are, they're engineers as well as software developers. It's so important to connect, what you can do with the code to how does it sound and how is it applicable in the real world to actual music. It's not just all about the ones and the zeros and throwing things into Plugin Doctor and looking at spectrums and all that stuff. It's how does this tool and this research get translated into something that's musical and useful in an engineering context. And it was really great to see and hear your walkthrough of Paragon and some of the use cases. I am certainly feeling really inspired to put it to use in some of my upcoming mix projects, and I think I'll be borrowing some of the examples of the way that you used it. So thank you so much for that, Freddie.
Oh, amazing. Yeah, thank you. Thanks for having me.
Right on. Well, yeah, I know it's in your evening there now overseas from me, and you've got a buddy that's waiting on you for a pint. So we'll wrap up there and let you get into your evening. But thanks again, Freddie, for joining us and showing us these demos. Really appreciate it, and I hope to be able to connect with you again soon.
Been a pleasure. Thanks a lot. Cheers.
Cheers.